Hi guys, that brings me to the next exercise of the chapter, exercise 21b. We are still on trigonometrical identities, but before I start a new question, let me just revise the three most important identities that we need to know. Sine square a plus cos square a is equal to 1. The next one is 1 plus tan square a is equal to sec square a. And then the last one was 1 plus cot square a is equal to cosec square a. No new concept which I need to teach you. Again, application of these three identities to solve questions. So let's look at it. This is cos a upon 1 minus tan a plus sin a upon 1 minus cot a is equal to sin a plus cos a. Again, obviously the left hand side is looking far more complicated, so I would start with the left hand side. And I also realize that on the right hand side I have only sin and cos, whereas on the left hand side I have tan and cot. So maybe I should try and convert all tan and cot into cos and sine. It'll help us get to the right hand side. So let's go. So this would be cos a upon 1 minus sin a upon cos a. I will need to write the reason as well, plus sin a upon 1 minus cos a upon sin a. And the reason would be since tan a is equal to sin a upon cos a and cot a is equal to 1 upon tan a. Perfect. So let's move on and see what does it do. So this would become cos a multiplied with, I will take the LCM in the denominator, which would be cos a, and then I'll change it from division sign into multiplication sign. So the numerator becomes cos a and the denominator of this term becomes cos a minus sin a. Perfect. So similarly in this term I will take the LCM of the denominator, the two terms in the denominator. The LCM would be sin a and the denominator now becomes sin a minus cos a. Perfect. Let's see if we can get something from here. So this gives me cos square a upon cos a minus sin a plus sin square a upon sin a minus cos a. I notice that the denominator of both these terms is exactly the same, except that the first one is x minus y, the second one is in the form y minus x. So we've done how to change the sign here. So let's use that method, which is I will multiply, or I'll take -1 common. So let's see how it works. Cos square a upon cos a minus sin a, and this is plus sin square a upon, in the denominator if I take negative sign common, then what I get is cos a minus sin a. Let's look at this step again. I have taken the negative out, which means this is negative cos a plus sin a, which is basically what I have. Now I'll take this negative sign outside, so this would become cos square a upon cos a minus sin a minus sin square a upon cos a minus sin a. So now I notice that the denominator is the same, so I'll take the LCM, which would be cos a minus sin a, and the numerator would become cos square a minus sin square a. The numerator is in the form of x square minus y square, which can be written in the form x plus y into x minus y. So this would become cos a plus sin a multiplied with cos a minus sin a, and in the denominator I have cos a minus sin a. I notice that there is one factor common between numerator and denominator, which is cos a minus cos a. It gets cancelled, and in the numerator I am left with cos a plus sin a, which is what my right hand side is, which is exactly where I needed to reach. So hence proved. Done. So interesting question. I started with the left hand side. I realized I have to reach sine and cos. That's why I converted tan and cot into sine and cos. I did basic arithmetic in terms of addition and subtraction. And this is where I realized that if I can change the sign of this, which means if I can put instead of plus negative here, I will have a common denominator. Perfect. Let's move on and let's solve the next question. The next question that we do is question number one, question 1, part 2. Again, a very interesting question. Let's see how we can solve it. So it has cos cube A plus sine cube A upon cos A plus sine A, and cos cube A minus sine cube A upon cos A minus sine A. So I can either add them up first, or if I remember the formula for this is in the form x cube plus y cube. So if I remember the formula for x cube plus y cube, then x cube plus y cube is equal to x plus y into x square minus xy plus y square. Let me see if that thing will help me do something. So let's look at this. So I can write this, the first term as cos A plus sine A, which is x plus y, multiplied with x square, which is cos square A, minus xy, which is cos A into sine A, plus y square, which is plus sine square A. And my denominator here is cos A plus sine A. I realize doing this makes my life simple because this term and this term will get cancelled. Now I will write it here. Continue. The second term would be in the form x cube minus y cube, which is x minus y, in this case cos A minus sine A, multiplied with x square, in this case cos square A, plus xy, in this case plus cos A dot sine A, plus y square, which means plus sine square A. And my denominator is cos A minus sine A. Again, this and this gets cancelled, this and this gets cancelled, but we'll still need to write the reason first. Since x cube plus y cube is equal to x plus y multiplied with x square minus xy plus y square. We did this in our algebra, so that's what I'm applying here. And the second thing I did was x cube minus y cube is equal to x minus y times x square plus xy plus y square. Perfect. So now that I've written the reason, what I'm left with in the numerator is cos square plus sine square, which means, let me just write this, this is cos square A plus sine square A minus cos A multiplied with sine A, cos A dot sine A. So all these three terms are taken care of. Next, what is remaining here is there is a plus sign in the middle, and this is again cos square A, this gone. Next is sine square A plus sine square A plus cos A dot sine A. Anything gets cancelled? Yes, negative cos A sine A and positive cos A sine A gets cancelled, and I am left with 2 times cos square A plus sine square A. Cos square A plus sine square A is 1, and this is also 1. This is equal to 2. So let me write the reason. Since cos square A plus sine square A is equal to 1, and this is equal to 2, which is my right hand side, hence proved. So nothing much in this question except that you needed to realize cos cube plus sine cube, which is x cube plus y cube, and you needed to remember this formula. Now how did I get into this? I realized it purely because of the fact that all the relations in the trigonometrical identities are in the square form. Sine square, cos square, tan square, sec square, cot square, cosec square. Which means if there is a cube, I will have to do something to convert it into square. That's the reason how I realized this, and that's the reason I applied x cube plus y cube formula. That's about it For this video, I'll see you with the next video. Bye bye.